Yes, hello. So while I'm here, I'm going to try to do 10-7, and I'm going to try to do it fairly fast because it's a little bit on just a few rules. We're now going to do complex numbers. Complex numbers. And they are A plus BI. This is the real part. And then we have the imaginary part. So in the beginning, we're just going to deal with imaginary parts actually. So you're going to learn the powers of I. The first thing you need to know is that the square root of -1 is I. Okay, you do need to know that. And then we're going to, in a little bit, expand on that. What's an I squared, I cubed, I to the 4th, etc. So the first thing you want to do is, how do you express in terms of I? Do you remember how before when we had, hey, simplify, and it said square root of -16, and we said not real, because at the time we didn't know how to deal with it. Well, in this case now we do know how to deal with it. We're going to simplify it. So let's do this one first. Could you write a square root of -9 as a square root of -1 and a square root of 9? You see? Could you then write that as a square root of -1, and then you could just separate them? Technically, you're using the product rule, and then you say 9 is a 3 squared. Could you then pull the 3 forward? Could you then call this square root of -1 is always I? So this is just going to be 3i. So just to get comfortable, this one here with the square root of -16, you wouldn't do this process every time. This is, you do this in your head, you know? You're going to say square root of -1 is an I, and this is where in the classroom, it's so much more fun because I can just say, hey, we're getting to the end of the semester, we're getting really frustrated, and let's get violent and pull the I out, you know? So we're going to actually, whenever you see a square root of a negative, you just pull the I out, and then a square root of 16 is 4, and this is, you immediately go into that. So all those things I can do in an on-ground class that are difficult here. The next one, hang on, I'm going to scroll. Now here you have to be a little bit careful. Yeah, I'm going to try to bring the next one up because that's the hard part. Okay. Number 2 here says simplify. Now people look at this and say, oh, I'm going to call that an I something. There's no negative under the radical, so you need to simplify this by saying, well, that's negative square root of 49 is 7 squared, so then the 7 comes out, so this is still a -7. But just realize the other ones, there was no negative. It did not create a negative. This thing here is not a negative number, okay? So I don't know what happened with my annotate. I'm just trying to use a regular blue pen. Square root of -150. So we're going to say, well, that's the square root of -1, which is an I, times the square root of 150. So 150. I'm going to make a tree. You might have a calculator. You could say 2 times 75, but how about we do a 15 and a 10 because that's easier mathematically. 5 times 5 is 5 squared times 3 times 2, you see? And then you say what comes out, what stays under, and you're going to lead with the number. So the 5 comes out, 5i square root of 3 times 2 is 6. Now you can say I always want to put the I in the end because it says A plus BI, you see? So this is the real part. So this isn't something we're actually dealing with yet. Right now, all we have going on is this term here, the BI, the imaginary part, the whole piece. sometimes if there's still a radical left, you might say, well, I want to put my number first and hang the I at the end. And I agree with you, but you have to be very careful, because if you enter this in, you have to make sure your radical stops right after the 6 and that your I is separate from it. The computer will take either as a final answer. Most of us prefer this. We hang the radical at the end, and it doesn't matter if we're a little sloppy and make it too long, it won't hurt anything. So let's see. I'm not gonna do all of these. On this one, what's important is that you don't forget this negative was there to begin with. Then you're gonna say square root of negative 36. So let's pull the I out of there, and square root of 36. So you could say, well, that's a 6 squared, so negative 6i. But it's only negative because it had a negative in front of it to begin with. Right in terms of I. 4 times square root of negative 1 is an I. And then you have square root of 9 times 11. So 3 squared times 11, right? 9 times 11. And then you would bring that 3 out. So you're going to have it 3 times the 4. That gives you 12 I square root of 11. That would be your final answer. Not the prettiest radical. So, and you might need to show more steps. Everybody's different. Let me see how many I have here. Let me see what else I have. Multiplying and dividing, subtracting and adding. Okay, so, oh yeah, and then we have to multiply, yeah. Okay, it still won't take very long. Okay, multiply. You know that if the index matches, you can go under. Here's the thing. You have to be careful when you're dealing with imaginaries, because if you just went under, you would have a negative times a negative is positive. And then you're actually ignoring the fact that you have to deal with imaginary numbers. These are both, you can't just make them real. So this first thing you do is call this I square root of 5, I square root of 10. Then you can say that's I squared 5 times 10. Instead of me saying that's 50, I'm going to say that there's a 5 inside the 10, so you have it 2 times the 5 squared. 5 squared is the 25 times 2 is 50, same thing as 5 times 10. And then I'm going to say I squared, the 5 comes out, the 2 stays under. Now here's a little problem. You don't know this yet. Square root of negative 1 is I, and then you're going to memorize a few things. I can prove them all. I squared is a negative 1. Then you have an I cubed. It's easier if you just memorize these few ones, is a negative I. And this is where people get confused. And I to the 4th is simply a 1. That one's my golden child, I call it. But so square root of negative 1 is I. And then these ones here, I'm telling you, just memorize them. It's just easier for you, okay? So memorize this box. And I can prove stuff, you know, I squared times I squared. Really, the only ones you absolutely have to memorize are these two. And then the rest of them you can derive. If I tell you it's I cubed, you could say, well, I cubed is I times I squared. I happens to be an I, and I squared is a negative 1, just accept it. Sometimes that's just easier, okay? And that's a negative I. So you can derive the others very easily. So, if you have a complex number or imaginary pieces, you can't ever use an exponent. They always have to be expressed as a plus bi. In this case, there's no a. It just happens to be a 0, but it's just that imaginary part here. There is no I square option, okay? So when you see an I squared, you need to replace it with a negative 1, okay? Not a square root, but a negative 1. So this is then 5 times I squared is a negative 1, and 5 times negative 1 is a negative 5. This just takes a little bit of practice. But just memorize these couple of things and you can work this stuff. Sorry, my dog is tiptoeing around. Also, if you're dividing, especially if it's a negative and a negative, make sure you deal with the imaginary part first, but you have an I square root of 42 over 3, square root of 3 is I square root of 42 over 3. So 14, right? So hang on a minute. I'm going to fix my own. I always fix my own mistakes fast enough. Can't erase it fast enough for you not to have seen it. In class, I can erase it and say, you didn't see that. You know, it's a square root of 14, so I'm going to say I square root of 14. Be careful with this. If that root extends over, you're going to have an issue. So it's always safer to write the I first. This is still the whole imaginary part. Doesn't have an A with it yet. Okay, next, then we're going to add and subtract. Actually, we're just going to subtract because I wanted to do the harder stuff. So if you're subtracting, remember this, just like in the olden days when we did chapter 5, 8 plus or polynomials, this is the same. Negative 1 times 9 is negative 9. Negative 1 times negative or negative times negative is positive. Then you combine like terms. So you need to have it in A plus BI. So your constants have to lead. So 8 minus 9 is negative 1. And then you have 3 apples plus 3 apples is 6 apples. Now, when you're multiplying, you're not multiplying radicals now, you're multiplying imaginary. So negative times negative is positive. 6 times 9 is 54. I squared. I times I is I squared. Then you have to say I can't answer with I squared. I squared is negative 1. Memorize that. So 54 times negative 1 is negative 54. Okay, so now we're going to multiply, and this is just like foiling back in the previous chapters. So first, 5 times 9, and then the outer and the inner, and then the last is 4i times I, so 4i squared. So this is where you have to be a little bit careful. Okay, so 45, I have 5i and 36i is 41i. But then I have a 4i squared, and I'm not allowed to leave the answer with an I squared. This isn't like you're doing polynomials where you lead with the x squared and stuff. I squared is negative 1. So this turns into a 45 plus 41i minus 4. Then you have like terms here. You see? So 45 minus 4 is 41 plus 41i. It's just coincidence that they're the same number. All right, next one. I'm trying to be fast because we still have a lot to do, it seems like, and it's lunchtime and I'm hungry. And you're tired of this. So here you do the same thing with this multiplying. If you notice A plus BI times A minus BI, the outer and the inner will actually cancel. Or you can always FOIL and then do it that way. Number 12, be careful. This is something I talk about in almost every section. You have a binomial squared. So you either FOIL or use formula. I'm going to FOIL because most of you do better with that. I don't know why this switches. I'm going to FOIL because most of you do better with that. 9 times 9 is 81. minus 72i minus 72i plus, and negative times negative is positive, 8 times 8 is 64i squared. And see, I'm not using the annotation. Okay, here, now you can see my pen. These two don't cancel, they combine. So I have 81 minus 144i. Sorry, my child is enjoying himself. 64 times, well, I squared is a negative 1. So we have 81 minus 144i minus 64. And I'm really tired, so I'm going to do this the old way. So I don't make a basic math mistake. So there's 17. Okay. So these two combine, and you have a 17 minus a 144i. Okay. Now, you're going to learn that write the quotient in the form of a plus bi. You'll learn that you cannot have an I in the denominator. Okay, so it's just like the radicals. You couldn't have a radical in the denominator. You had to rationalize the denominator. So here then I call it, you need to real the denominator. Nobody uses that term. But that's essentially what we're doing. We're getting rid of the I in the bottom. How do we do it? Think about it. If you multiply this times I, whatever you do down here, you do up here, then it's making it legal. This is essentially multiplying this whole piece times 1, totally legal. And then you have a 5i over I squared. And why did I do that? Because then I could take and turn the I squared into a negative 1, because I've accepted that I squared equals negative 1. And then you have a negative 5i, essentially. So we're going to do another one. You can always pause these, so just remember that when you get frustrated with me if we're going too fast. You can pause. This one here, if you take the numerator and you factor it out, you could work it that way. You see how they both have a 7? No, well, okay, let's look at it. I need to create a denominator that does not have an I. Yes, you could multiply this thing by 2i, but why don't I just multiply it by I? You see, so this is how I do it. Some people say, hey, I'm just gonna multiply it by itself. Other people say I'm gonna multiply it by its conjugate. I'm going to go ahead and I do the littlest I have to it. So that leads me to denominator 2i squared, which leads me to 2 times negative 1, which leads me to a negative 2 in the denominator. If I just look at denominators first, the numerator, you're gonna distribute I times 14 is 14i, and then I times negative 7i is negative 7i squared. I squared is a negative 1. So it's a 7 plus 14i. Now here's the problem. It doesn't help me to pull a 7 at all. I need to do this in the form of a plus bi. That's the rule. And they need to be separate pieces, okay? A real part and then the imaginary part. Do you see how here this is all one term? It's all really imaginary. So you need to split them up and say that's negative 7/2 and 14i divided by negative 2. You see, plus 14i divided by negative 2. And that then simplifies into a negative 14 divided by 2 is 7. So this is a little bit odd, but you need the real part first and then the imaginary part. Now, the last thing we're going to do is find the powers of I. So this section can be a little hefty. Hang on, folks, we're almost done, okay? So just bear with me. Okay. the powers of I. Okay, your options for a final answer are the following. I squared is -1, negative I, and 1. Those are your 4 options, because this is the square root of -1 is I, and then I squared was the -1, and I cubed was the -I, and I to the 4th is a 1. And I told you memorize the first 2, and then you'll be fine. But this is what, these are options. So let me show you one. I to the 44th power. My golden child is I to the 4th. That's the one that I want. If I can make it happen, I'm going to make that happen. Could you write I to the 44th as a bunch of I to the 4th? You see it? And you would have to have them over and over and over again. But could you write it like this? And why am I doing this? And you're going to think, why didn't she put the 4 on the outside? And this is a little different. 4 times 11 is 44, so you agree with me that that would happen. And I to the 4th is 1. You see, this is what I really wanted. I wanted this to be a 1. I to the 4th is 1. 1 to the 11th is just 1 times 1 times 1 times 1 times 1 times 1 times 1, 11 times, so you're still going to get a 1. You see it? So if exponent evenly divisible by 4, then that turns into 1 automatically. So let me show you another one before I move on. Into 1, not 1I, but just 1 as a final answer. Okay, so what if I have I to the 80th? I could write that as I to the 4th to the what? And you're going to say 20, right? And then I could say I to the 4th is a 1, and 1 to the 20th is what? 1 times itself 20 times is still a 1. You see it? So do you see how this exponent is evenly divisible by 4? This exponent is evenly divisible by 4. So any one of them that has an exponent evenly divisible by 4 automatically final answer 1, okay? So that's that scenario here. What about this? Find the power of I to the 25th. Not evenly divisible by 4. Could I split it into something evenly divisible by 4? So I could say that's I to the 24th times what? I to the 24th times I is I to the 25th. I to the 24th, I'm going to say I memorized. Sometimes memorizing in math is good, really, just the basic rules and little tricks and stuff. This exponent is evenly divisible by 4, so this whole piece just turns into a 1. And 1 times I is I, you see? So in this case, this is your final answer. I to the 25th simplifies into an I. I to the 44th simplifies into a 1. I'm going to do 1 or 2 more examples. Actually, I'm going to do them right here in green or something. Okay. What if I had I to the 38th? You see? Then you're going to say, well, what could I split it into something that is evenly divisible by 4? Or how about a 36? And then how many more do I need to make 38? I squared. This piece here, you could go through this process every time this process over here And you could write it as I to the 4th to the 9th in that case, but it doesn't help you. It's just simply a 1. Just let it be, okay? Just take those little hints, memorize those little things, and just let it be a 1. And then what is I squared? I squared is a -1, you see? And then 1 times -1 is -1. So that's your third option. You see how we have, I'm trying to get you every single scenario that could happen. So you might have a final answer 1, you might have a final answer I, you might have a final answer -1. What else would we maybe have? A negative I, you see? So what if I had, last one, I to the 27th, you know, then you're gonna say, well, I could split that into I to the 24th times I cubed. 24 is evenly divisible by 4. It's close to 27. If I do 28, it's too big, so you can't do that. And then I to the 24th is just simply a 1 because you accept it. And then I cubed, we had to memorize from over here, and that's just a -I. So this gets confusing for students, but here is Spotlight. Your options are, oops, where's my Spotlight? Your options are, oh, what do I do with this? It's not moving. Why won't it move? Oh, okay, forgive me for having technical difficulties. Oh, it won't show me, but anyway, your options for final answers are I or -1 or -I and or a 1. And we've covered all of those scenarios. So let me know as you have questions. Oh, here it is, the Spotlight with my mouse, not with my pen. So anyway, those are your options and you have to make that happen. So thank you, and I will see you in class, hopefully.